Andrej Karpathy, former director of AI at Tesla and a founding member of OpenAI, experienced a radical shift in his daily work last December. His manual coding dropped from 80% to 0. He simply stopped typing raw code. Instead, he entered what he calls AI psychosis, an intense, almost addictive state where he spends 16 hours a day manifesting his goals through machines, completely detached from the keyboard. This is different from typing a single prompt into a chatbot and waiting for a reply. Karpathy now commands swarms of autonomous AI agents running in parallel, executing complex tasks simultaneously. The physical act of programming is effectively obsolete for him. The engineer has evolved from a typist into a high-level conductor directing machine labor. In this new workflow, the metric of success is token throughput. A token is basically a chunk of a word or data that an AI processes. So throughput measures the sheer volume of information a person can manage and verify at once. A human maximizes this throughput by acting as a central hub, managing 10 different agent sessions at the same time, with each agent tackling a different software repository. When one of these AI agents fails to complete a task, Karpathy notes that it is now considered a human skill issue. The failure usually stems from poor prompting or bad tool setup by the conductor, not a limit of the machine itself. Because human management speed is the final limiting factor in this process, the next logical step for the tech industry is to remove the human bottleneck entirely. We are entering what researchers call the loopy era, a time when AI operates in continuous, persistent loops. Karpathy built a home automation agent named Dobby to test this concept. Without any human input, Dobby scanned his local network and reverse-engineered the APIs, the hidden code languages devices use to talk to each other, for his Sonos speakers, the security cameras, and smart lights. This leads to the Dobby thesis. If an AI can directly control devices through their code, graphical user interfaces, the visual menus and buttons we tap on our screens, become entirely obsolete. The traditional apps built for human eyes will dissolve, replaced by raw data pipelines operated entirely by digital claws acting on our behalf. The primary consumers of future software will not be humans at all, but relentless, invisible digital agents. This autonomous capability scales from smart homes directly into enterprise laboratories. Karpathy recently launched a project called Auto Research to automate machine learning experiments. By using a simple text document called program.md, an entire human research organization is transformed into an editable code file that an AI can follow and execute. These agents run loops of experiments overnight. In Karpathy's case, the AI discovered complex mathematical optimizations that he had missed, despite his 2 decades of experience in the field. This highlights a phenomenon called jagged intelligence. AI excels at highly verifiable tasks, like compiling code or tuning models, but it still stagnates in subjective, soft domains, like writing jokes or understanding nuance. Millions of these highly capable agents are about to flood the global internet to perform these rigid tasks, requiring new digital infrastructure to route them. To see how digital infrastructure affects the physical world, look at the Caribbean island of Anguilla. Anguilla accidentally created a massive digital endowment when assigned the .ai country code domain in the 1990s. This chart shows the exponential growth of .ai domain revenue. AI registration fees now fund 16% of Anguilla's GDP and half its government budget. That digital capital is directly deployed to fund local public goods, paying for healthcare and airport expansions. Anguilla serves as the world's first working prototype, proving that AI namespace economics can successfully fund a physical social safety net. Economists point to the Jevich paradox, stating that as the cost of a resource drops, its use actually increases. As the cost to produce software drops to near zero, the demand for autonomous agents will explode. Hundreds of trillions of these incoming agents will absolutely require trusted cross-web identities, like .agent or .agi domains, to operate securely. By applying protocol-level registration and transaction fees to these digital identities, the capital generated by machine labor can be aggregated into a single system. This neutral identity infrastructure could systematically fund a high universal basic income for humanity on a global scale. Infrastructure is destiny. we have a brief window to actively design the AI financial architecture before the AI economy passively designs us.